Welcome back, students. Again, we will discuss one more example based on an evaluation of a double integral by converting into polar coordinates. And this example is once again, it is very easy. So that is, you can start with I. Okay. So before that, as you people already aware that we are going step by step. If the limit containing the variable y, it corresponds to x, the remaining variable is y only. So assigning the variable to the limits of integration is over. Then next we are going to draw the geometrical representation of a double integral, or how these double integral looks, or what is the existence reason, or what is the reason of integration we are going to draw. Okay, first you can draw x-axis and y-axis. Okay, y-axis, x-axis, origin, and you people know that what does y is equal to 0? Y is equal to 0 is the equation of x-axis. Okay, and y is equal to a is somewhere here. This is y is equal to a. Okay, then what does x equal to 0? X equal to 0 is this equation of y-axis. X equal to 0 is equation of y-axis, and remember, what does y is equal to a? Line parallel to x-axis. And what does this? This is again x is equal to, right? X is equal to square root of a square minus y square. On squaring on both sides, it will become x square is equal to a square minus y square. The square root and square get cancelled. Bring minus y square to left side. X square plus y square is equal to a square. So what does it represent? It represents a circle with the center at 0, 0 and radius a units, that is r is equal to a. So therefore, how does it will look? Okay, just to draw a circle. So this is the circle, and remember the reason of integration. Reason of integration is it starts from lower part. Lower is y is equal to 0 to y is equal to a, means it will calculate area between these two lines, and we don't want the area between these two lines, so left side start with. So this is the lower portion, upper portion is over. Left side start with x equal to 0, and right side means a curve. Right side means a curve. Curve is a circle, so we need to integrate the first quadrant of a circle. We need to find the area of first quadrant of a circle, and if I want to express in terms of a polar, first I am going to substitute x equal to r cos theta and y is equal to r sin theta. These are the test substitution, and we people already know that x square plus y square is equal to r square. On squaring and adding, you will get r square cos square theta plus r square sin square theta. You can take r square common. You will get cos square theta plus sin square theta is equal to 1. 1 into r square is r square. Then you also know that dx dy is equal to r dr into d theta. Further, r varies from, and what does the value of theta? What is the starting point and ending point of the theta? Just look at the radius of this circle. Radius starts from 0 to this total final value is, this is a. So r varies from 0 to a, and theta means this is theta. Theta varies from, this is 0, this is pi by 2. This is pi, we know already in the previous example. So theta varies from only 0 to pi by 2, since it's a first quadrant. So this is 0 to pi by 2. Okay. Now let us write the integral again. I is equal to, either write r first or theta first, doesn't matter. Okay. So therefore, first I will write r value. R runs from 0 to a. Okay. Then theta runs from 0 to pi by 2. Okay, and look at this y, keep it y value is r sin theta, and square root of x square plus y square is r square. Okay, you can write square root of r square, and dx dy is equal to r dr into d theta. Okay, fine. So now, okay, fine. Now, which is equal to r runs from 0 to a, theta runs from 0 to pi by 2. This is r sin theta, keep it as it is. This is square root of r square is r into r is r square into r is, this is r cube into sin theta into, you can write d theta into dr, or you can write dr into d theta, doesn't matter because the limits are constant. So first I am going to integrate with respect to theta. Okay, for that r runs from 0 to a, keep it as it is. Okay, now with respect to theta, r cube is the constant, I am writing outside. The integration of sin theta is, which is minus cos theta between the limits 0 to pi by 2 into dr. So first integral varies from 0 to a, this is take minus sign outside, r cube into upper limit cos pi by 2 minus lower limit is cos 0 into dr. Cos pi by 2 value is 0, cos 0 is 1, 0 minus 1 is 0 minus 1. I will rewrite once again, minus of r runs from 0 to a, this is r cube, this is minus 1 into dr. I is equal to this minus minus plus, integration of r cube is r raised to 4 by 4 between 0 to a. Substitute upper limit, that is a raised to 4 r by a raised to 4 by 4 minus lower limit is 0 raised to 4 by 4. This is just a raised to 4 by 4 minus 0 by 4 is 0. So this is the value of a double integral by converting into polar form. Thank you so much for watching. Please subscribe my channel CGAT Maths, or Creative Guide Advanced Tutorial for Mathematics. Please subscribe it, share our videos, please like it. If you find any difficulty while understanding, please feel free to comment. Thank you so much.